There is an invisible object drifting through our galaxy right now. No light. No signal. No warning. And according to evidence published in peer-reviewed journals, one of them may have already passed closer to our solar system than we ever imagined. In the next 8 minutes, you're going to understand exactly what a stellar mass black hole is, why we almost never see them, what astronomers actually discovered drifting through the Milky Way, and why that changes everything we thought we knew about how safe this galaxy really is. Here's the thing most people get wrong about black holes. They picture them as cosmic vacuum cleaners, enormous, hungry, sucking everything in. But the majority of black holes in our galaxy are nothing like that. They are quiet, patient, completely invisible. And there are almost certainly millions of them, scattered throughout the Milky Way right now, drifting between the stars like dark matter ghosts we've never learned to see. These are called stellar mass black holes. They form when massive stars at least 20 to 30 times the mass of our own Sun, reach the end of their lives and collapse. The outer layers explode in a supernova, and what's left behind is a singularity. A point of infinite density wrapped inside an event horizon. An object with the mass of 10, 20, sometimes 50 suns, compressed into a sphere roughly the size of a city. And here's where it gets strange. Our galaxy should contain somewhere between 10 million and 1 billion of these objects. 10 million to 1 billion. Yet as of just a few years ago, we had confirmed the existence of fewer than 20. 20. Out of potentially a billion. So where are they all? The answer is chilling. They're out there. Drifting. Dark. And we simply cannot see them. Unless they happen to pass in front of a star. The only way to find a free-floating, isolated black hole is through a phenomenon Einstein predicted over 100 years ago. It's called gravitational microlensing. And the concept is both simple and deeply unsettling. When a massive object passes between us and a distant star, its gravity bends the light from that star. The star appears to brighten, sometimes dramatically, and then dim again as the object moves on. Like a lens made of warped spacetime passing in front of a flashlight. You never see the lens. You only see the light behave in a way it shouldn't. Astronomers have been watching for these brightening events for decades, scanning millions of stars in the dense core of our galaxy using programs like OGLE, the Optical Gravitational Lensing Experiment, and the Hubble Space Telescope. Most microlensing events turn out to be caused by ordinary objects. Dim red dwarf stars. Rogue planets. Brown dwarfs, failed stars that never quite ignited. But sometimes, an event behaves differently. The lensing lasts too long. The magnification is too intense. The object causing it is too massive, and has no detectable light of its own. Those are the events that make astronomers put down their coffee and stare at the data again. Because those events have a signature. The signature of something dark. Something massive. Something that should not exist in empty space but clearly does. In 2022, 2 independent teams of astronomers analyzed the same microlensing event. An event cataloged as MOA 2011 BLG 191 and OGLE 2011 BLG 0462. It had been observed a decade earlier, a star in the direction of the galactic bulge that brightened and dimmed over the course of nearly 300 days. 300 days. That's 6 times longer than a typical microlensing event. Something enormous had drifted across that line of sight. Both teams modeled the data. Both teams reached the same range of conclusions. The object causing the lensing had a mass somewhere between 1.6 and 4.4 times the mass of our Sun. It was moving at roughly 45 kilometers per second relative to Earth. And it emitted absolutely no light whatsoever. None. One team concluded it was almost certainly a neutron star or a black hole. The other team went further. They said the data pointed most strongly to a black hole. A free-floating, isolated, stellar mass black hole. drifting alone through the galaxy. The first, ever, directly inferred from microlensing data alone. But before we get to exactly what that means for you, for this solar system, and for everything traveling through this galaxy right now, you need to understand something even stranger about where this object is going. Here is what that discovery actually means, and why it should stop you cold. That single confirmed rogue black hole, drifting through the inner Milky Way, invisible, detected only because it accidentally wandered between us and a distant star, is not alone. It is one data point in what astronomers now believe is an enormous, invisible population. Statistical models built from microlensing surveys suggest there could be 200 million free-floating stellar mass black holes in our galaxy. 200 million dark, city-sized objects, each carrying the mass of multiple suns, scattered throughout the same galaxy you live in. And here is the part that makes this viscerally real. The nearest one to us right now, we have absolutely no idea where it is. It could be 1,000 light-years away. It could be 50. There is a non-zero probability, astronomers have actually calculated this, that a rogue black hole has passed within 1 or 2 light-years of our solar system within the last few million years. Silently. Invisibly. Close enough that it would have gravitationally nudged comets in the outer Oort cloud, and we would have had no idea what caused it. That slight gravitational tug on the outer edge of our solar system? It may already have a name. We just don't know it yet. Now, before your brain starts catastrophizing, let's be precise about the actual risk. The galaxy is incomprehensibly large. Even with 200 million rogue black holes drifting through it, the distances between objects in interstellar space are so vast that a direct collision with our solar system is extraordinarily unlikely on any human timescale. We're talking probabilities so small they become almost philosophical. But that's not actually the point. The point is this. For decades, we looked up at the night sky and thought we understood what was out there. We catalogued the stars. We mapped the nebulae. We tracked the planets. And the entire time, the galaxy was filled with an invisible population of objects we couldn't see, couldn't detect, and could only infer by the way they bent light as they passed in the dark. The universe is not just stranger than we imagined. It is stranger than we are currently capable of imagining. And we are just beginning to learn how to look. The first confirmed free-floating black hole. 200 million invisible objects sharing this galaxy with us. A cosmos where the most dangerous things are the ones we cannot see. That is not science fiction. That is the peer-reviewed, Hubble-confirmed state of our universe right now. If this broke your brain a little, subscribe. We drop one of these every week. And next time, we're going to talk about something that might actually be even stranger. There is a region at the center of our galaxy where stars are moving so fast, in such tight orbits, that physicists had to invent new explanations for what's pulling them. Most of those explanations weren't black holes. So what was it? We'll see you there.